October 10th, 2024. Warner Brothers Studios, California. Guests arrived expecting to witness Tesla's long-awaited robotaxi reveal. Instead, they found themselves standing face-to-face with humanoid robots. Some served drinks. Others handed out gift bags. A few even played rock, paper, scissors with attendees. For a brief moment, it felt as though the future had arrived years ahead of schedule. Then Elon Musk walked onto the stage and made a claim that seemed even more unbelievable than the robots themselves. Tesla's future, he suggested, might not be defined by electric cars at all. It could be defined by Optimus, a humanoid robot that he believes has the potential to become one of the company's most important products. Musk described a future where robots could perform almost any everyday task and eventually cost around $20,000 to $30,000, roughly the price of an average family car. To many people, the idea sounded absurd. Tesla had spent 2 decades becoming one of the world's most valuable automakers. It had survived near bankruptcy, challenged century-old manufacturers, and helped push electric vehicles into the mainstream. Why would the company suddenly place so much attention on a robot? More importantly, why would investors even take that idea seriously? Some analysts and investors have suggested that if general-purpose humanoid robots become practical and widely adopted, the market opportunity could eventually reach tens of trillions of dollars. Those numbers are forecasts rather than facts, and they depend on extraordinary technological and economic assumptions. But they reveal something important. The real conversation isn't about whether Optimus is impressive today, it's about whether Tesla is trying to build the first truly scalable digital workforce. Every economy on Earth runs on one invisible resource: labor. It exists behind every product we buy and every service we use. A hospital depends on nurses, technicians, cleaners, and doctors. A supermarket relies on warehouse workers, truck drivers, cashiers, and shelf stockers. Even a simple cup of coffee requires farmers, transport companies, factory workers, logistics networks, and baristas. We often think economies are powered by money, but money alone produces nothing. It is human effort that transforms raw materials into homes, food, medicine, technology, and infrastructure. Labor is the engine that keeps civilization moving. That engine, however, has always had one limitation. There are only so many people. Every nation faces the same constraint. Workers need rest. They retire. They become sick. Populations age. Birth rates decline. Many developed countries are already experiencing labor shortages in healthcare, manufacturing, logistics, and construction. Businesses aren't always struggling because they lack customers. Increasingly, they're struggling because they can't find enough people willing or available to do the work. In that context, Elon Musk's fascination with humanoid robots begins to make more sense. Optimus isn't simply a machine. It's an attempt to expand the global supply of labor without increasing the global population. At first glance, that might not seem revolutionary. After all, factories have been using robots for decades. Walk into a modern automobile plant, and you'll find robotic arms welding steel, lifting heavy components, and painting vehicle bodies with incredible precision. But those robots have one major weakness: they are specialists. A robot designed to weld a car door cannot suddenly unload a truck. A warehouse robot cannot assist a nurse in a hospital. Every industrial robot is built for a specific environment and a specific task. Optimus is trying to solve a completely different problem. Tesla isn't building another industrial machine. It's attempting to build a general-purpose worker. That distinction changes everything. Imagine a machine that can carry boxes in the morning, stock shelves in the afternoon, assist factory workers in the evening, and eventually help an elderly person around the house. One body, thousands of possible jobs. Suddenly, the addressable market isn't just automotive manufacturing, it's every industry that depends on repetitive physical work. That's why discussions around Optimus often focus less on robotics and more on labor economics. If a general-purpose robot becomes affordable, reliable, and safe, it doesn't compete with forklifts or conveyor belts. It competes with one of the largest markets in the world: human labor itself. This is also why Tesla's strategy looks different from that of most robotics companies. Elon Musk often describes Tesla as much more than a car manufacturer. The company develops batteries, electric motors, artificial intelligence, manufacturing systems, and computer vision software. In many ways, every Tesla vehicle is already a robot. It constantly observes the world through cameras, interprets its surroundings using neural networks, and makes driving decisions in real time. Musk has even referred to Tesla vehicles as robots on wheels. Optimus takes many of those same technologies and places them inside a humanoid body. The company hopes that years of investment in artificial intelligence, perception systems, and manufacturing can accelerate progress in robotics. Whether that advantage proves decisive remains uncertain, but it explains why Tesla believes it is uniquely positioned to pursue such an ambitious goal. Still, believing something is possible and proving it are two very different things. Walking across a stage is impressive. Working 8 hours inside a busy factory is something else entirely. Humans perform thousands of tiny actions every day without thinking about them. We adjust our balance when climbing stairs. We grip fragile objects without crushing them. We recognize hundreds of household items instantly, even when they're partially hidden. Teaching a machine to perform those same actions reliably is one of the hardest engineering challenges ever attempted. A robot must understand its surroundings, react safely to unexpected situations, and continuously make decisions in an unpredictable world. That's a much higher standard than simply demonstrating a few carefully rehearsed tasks. The demonstrations themselves have also attracted scrutiny. Shortly after Tesla's We Robot event, reports indicated that some of the robot's interactions with guests involved remote human assistance, rather than being fully autonomous. That doesn't mean the technology lacks potential, but it does illustrate how much development still lies ahead before humanoid robots can operate independently in complex, real-world environments. And perhaps that's the most fascinating part of the Optimus story. The biggest question isn't whether Tesla can build a robot that walks, dances, or serves drinks. The biggest question is whether it can build one that's useful enough, affordable enough, and reliable enough to change how the global economy thinks about work. Because if that day ever arrives, Optimus won't simply become another Tesla product. It could become the first machine that forces humanity to rethink one of its oldest assumptions, that productive labor must always come from people. If Tesla succeeds, the biggest disruption won't happen inside a factory. It will happen inside an accountant's spreadsheet. Every business in the world asks the same question every day: how do we produce more while spending less? For centuries, the answer has almost always involved people: hire more workers, train them, manage them, pay salaries, provide benefits, deal with turnover. Human labor has never simply been a cost. It's also been one of the biggest constraints on growth. A company can only expand as fast as it can recruit skilled employees. Elon Musk believes that equation could eventually change. If a general-purpose robot becomes affordable enough to perform useful work safely and reliably, businesses won't just be buying a machine. They'll be buying productive hours that don't retire, don't call in sick, and can be updated with better software over time. Whether that vision becomes reality is still uncertain, but it's the economic logic behind Optimus. Imagine a warehouse employing 1,000 workers. Not everyone performs highly specialized tasks. Many spend their shifts moving inventory, transporting materials, loading pallets, or preparing shipments. These jobs are physically demanding, repetitive, and increasingly difficult to fill in many countries. Now imagine that a portion of those repetitive tasks can be handled by humanoid robots, while human employees supervise operations, solve unexpected problems, and manage exceptions. Productivity increases, injuries decline, and businesses become less vulnerable to labor shortages. This is why many robotics companies, including Tesla, Figure AI, Agility Robotics, and others, are initially targeting warehouses, logistics, and manufacturing rather than family homes. These environments are structured, repetitive, and economically easier to automate, but factories are only the beginning. If Optimus becomes more capable, the addressable market expands dramatically. Hospitals could use humanoid robots to move medical supplies, transport equipment, or sanitize rooms, allowing healthcare workers to spend more time with patients. Hotels could automate housekeeping support. Farms facing seasonal labor shortages might deploy robots for repetitive agricultural tasks. Airports could use them for baggage handling. Retail stores could automate inventory management. Even construction companies, where labor shortages continue to affect projects worldwide, could eventually integrate humanoid assistance for repetitive lifting and material transport. Each of these industries has different requirements, different regulations, and different safety standards, but they all share one thing in common: they rely heavily on human labor. This is where the $25 trillion conversation begins. That number isn't Tesla's valuation, and it isn't the current value of Optimus. It's a speculative way of describing the enormous economic value of global labor if general-purpose robots eventually become widely adopted. Some investors and analysts use trillion-dollar figures to illustrate the size of the opportunity, not to predict guaranteed outcomes. The important point isn't the exact number. It's the realization that labor represents one of the largest markets on Earth. If even a small percentage of repetitive physical work becomes automated, the economic impact could be enormous. But enormous opportunities don't automatically become successful businesses. History is full of technologies that promised revolutions, but never achieved widespread adoption. And that's where Optimus faces its greatest challenge. Building an impressive prototype is not the same as building millions of reliable products. Tesla has demonstrated rapid progress over several generations of Optimus, and the company says its long-term goal is a general-purpose autonomous robot capable of performing unsafe, repetitive, or boring tasks. Yet robotics experts continue to point out that operating safely in unpredictable environments remains one of the hardest problems in engineering. A robot must understand context, recognize thousands of different objects, recover from unexpected situations, and work safely around children, elderly people, pets, and other workers. That's an entirely different level of complexity from performing pre-programmed demonstrations. Tesla has also faced criticism over how some public demonstrations were presented. During the 2024 We Robot event, several reports indicated that many of the robot's conversations and interactions with attendees involved remote human assistance, even though the robots were able to walk autonomously. Critics argued that this made it difficult to judge the technology's true capabilities, while supporters countered that teleoperation is a common step in robotics development and provides valuable training data for future autonomous systems. Both perspectives can be true at the same time. The demonstration showed meaningful progress, but they also highlighted how much work remains before fully autonomous household robots become reality. Competition is another factor often overlooked. Tesla isn't building Optimus in isolation. Companies such as Figure AI, Agility Robotics, Boston Dynamics, Apptronik, Unitree, and several Chinese robotics firms are all racing toward the same goal. China has publicly identified humanoid robotics as a strategic industry and aims to accelerate domestic production over the coming years, while American companies are investing heavily in AI software, sensors, and advanced manufacturing. The race is no longer about who builds the first humanoid robot. It's about who builds the first economically useful one at scale. Even if Optimus becomes technically successful, society will still face difficult questions. What happens to workers whose jobs become partially automated? How should governments respond if productivity rises much faster than employment? Should robots be taxed? Who owns the data collected by machines operating inside homes? How do regulators certify robots that work alongside humans? Every major technological revolution has forced societies to create new laws, new institutions, and new ways of thinking. Humanoid robots are unlikely to be any different. Perhaps that's why Elon Musk speaks about Optimus with such confidence. He isn't simply imagining a better robot, he's imagining a different economic system, one where physical labor gradually becomes abundant rather than scarce. Whether that future arrives in 5 years or 30 years is impossible to predict. Musk himself has often set ambitious timelines that later proved optimistic, while still succeeding in pushing industries toward goals many people once considered impossible. The same pattern may repeat with humanoid robotics. Progress could be slower than enthusiasts expect, faster than skeptics believe, or follow a path that nobody anticipates. But regardless of the timeline, one thing is becoming increasingly clear. Artificial intelligence is giving machines the ability to think. Humanoid robotics is giving them the ability to act. If those two technologies continue advancing together, the question may no longer be whether robots become part of the workforce. The question will be how large a role they eventually play within it. And perhaps that's the real reason Elon Musk believes Optimus matters so much. Not because it will replace every worker, not because it will instantly create a multi-trillion-dollar industry, but because for the first time in history, humanity is attempting to build a machine that can learn, adapt, and contribute across thousands of different kinds of work. If that experiment succeeds, the most valuable product Tesla ever builds may not have 4 wheels. It may walk through the front door, shake your hand, and quietly begin doing the jobs nobody wants to do. And when that day arrives, the real revolution won't be that robots have become more like humans. It will be that human labor is no longer the only engine capable of powering civilization.